Alzheimer's disease has long been painted as an unsolvable mystery, a shadowy monster built from plaques and tangles that slowly dismantle memory and identity. For decades, researchers threw everything they had at those plaques, treating them as the prime villains. And yet, time and again, therapies aimed at breaking down amyloid deposits failed to deliver the miracle. But what if the real story has been hiding in plain sight, in something as ordinary and relatable as fat? That's the fresh perspective emerging from Purdue University's latest research, and it's not just scientifically groundbreaking, it's oddly reassuring. The new picture is one where our brain's immune cells, called microglia, act less like passive bystanders and more like characters we can actually relate to. Imagine them as the overworked, slightly overfed janitors of the brain. They start off lean, efficient, constantly patrolling, gobbling up unwanted proteins and sweeping debris away. But over time, especially in the presence of Alzheimer's stressors, they begin to hoard fat. Instead of keeping the place clean, they get weighed down. They're still there, still present, but too sluggish to do what they were designed to do. This changes how we think about the disease. It's not that the brain is inherently doomed to collapse under plaques and tangles. It's that the immune cells that should be protecting it are distracted, bogged down by their own chubbiness. And the good news is, if weight gain is the problem, weight loss, at least at the cellular level, can be part of the solution. Purdue's team showed that when you target the fat-making process in these microglia, particularly by addressing the enzyme DGAT2, the cells can slim back down, shake off the lethargy, and return to fighting mode. That's not just clever science, that's hope. And the hope here isn't just abstract. It speaks to a vision of treatment that feels far more natural and supportive than previous approaches. Instead of developing ever more aggressive drugs to destroy plaques directly, this strategy nurtures the brain's own built-in defenses, giving microglia the tools to do their job again. It's the biological equivalent of personal training. Rather than sending in outsiders to clean up the mess, you re-energize the original cleanup crew. That's a positive story, because it means our brains are not fundamentally broken in Alzheimer's, they're simply in need of recalibration. There's also something wonderfully humanizing about this discovery. The idea that our brain cells can get sluggish from too much fat mirrors our own lives in a way that feels almost comforting. Who hasn't felt the heaviness after a holiday meal, or the slump of carrying just a little too much weight? And just like people can bounce back with the right balance of diet and movement, these microglia show they, too, can bounce back if you help them manage their fat better. The parallel makes the science less abstract, more accessible, and surprisingly optimistic. Even more promising is the ripple effect of this new perspective. If fat metabolism plays such a key role in microglial health, then Alzheimer's might not be the only disease influenced by this pathway. Other conditions tied to inflammation and aging in the brain could also benefit from approaches that fine-tune how immune cells handle fat. What looks like a small discovery about chubby microglia could, in fact, be the doorway into a whole new field of therapies aimed at restoring balance across multiple neurodegenerative diseases. So instead of despairing at the idea of an unstoppable disease, we can start to imagine a more positive picture. A brain that's not falling apart irreversibly, but one that's cluttered, slowed down, and simply in need of help managing its inner environment. A disease that may not require a sledgehammer to fight, but rather a thoughtful rebalancing act that supports what the brain already knows how to do. That's an uplifting change of narrative, from inevitability to possibility, from defeat to strategy. And there's an extra layer of positivity here. Science often feels cold, detached, focused on chemistry and genes. But this discovery brings in a sense of relatability. It's funny and familiar to imagine immune cells hoarding fat the way we do. It makes the problem less alien and the solutions more approachable. Instead of staring at frightening images of deteriorating neurons, we can picture microglia getting back into shape, dropping their lipid baggage, and springing into action again. It's not just science, it's a story of resilience, recovery, and renewal. When you look at it this way, the whole field of Alzheimer's research feels less like chasing an unreachable cure and more like discovering new ways to give the brain what it needs. Fat, once thought of as a meaningless byproduct in the brain, has turned out to be a central player. And by tackling fat in a smart way, scientists aren't just tinkering at the edges, they're rewriting the rules of the game. It's a reminder that biology, for all its complexity, often circles back to simple truths. Too much of anything, even fat in the wrong place, can weigh us down. But with balance and the right interventions, life and function return. For Alzheimer's, that might mean a future where the disease is not an unavoidable sentence, but a condition we can prevent, manage, or even roll back. And that's not just positive, that's transformative.